Hello everybody, welcome to the channel Learn to Earn for Life.
Dear students, in this video I will tell you how to obtain the per unit impedance diagram or the per unit reactance diagrams. In the previous sections I have told about how to draw the impedance diagram and reactance diagram from the given one line diagram. So in this video I will be telling how to obtain the per unit impedance diagram and per unit reactance diagrams. So these diagrams, in these diagrams the impedance or reactance of the components are not expressed in their ohmic values, but they are expressed in per unit values expressed on a common base. So this greatly simplifies the task which is involved in the analysis of the power system. Let me tell you the procedure to form the per unit reactance diagram or the per unit impedance diagram from the given one line diagram. From the given one line diagram of a power system, we can directly draw the per unit reactance or per unit impedance diagram by the following procedure. The first step is we need to choose the base kVA or the base MVA. So this value remains same for all the sections of the power system, and preferably this value be the rated kVA or rated MVA of one of the electrical apparatus of the system. In case of three-phase power system, the kVA base or MVA base is the three-phase power rating. The second step is select the base kV for one section of the power system. In case of three-phase power system, the kV base is a line-to-line value. This should preferably be the rated kV of the apparatus whose power rating has been taken as the base. The various sections of the power system works at different voltage levels, and the voltage conversion is achieved by means of transformers. Hence, the kV base of one section of the power system should be converted to kV base corresponding to the another section using the transformer ratio or the transformer voltage ratio. In case of three-phase transformer or a bank of three single-phase transformers, line-to-line voltage ratio is used to transfer the kV base on one section to another section. kV base on primary winding of a transformer or kV base on primary side of the transformer is equals to kV base on a secondary winding of a transformer or kV base on a secondary side of the transformer into primary winding given voltage rating divided by secondary winding given voltage rating. kV base on secondary winding of the transformer or kV base on a secondary side of the transformer is equals to kV base on primary winding of a transformer or kV base on primary side of the transformer into secondary winding given voltage rating divided by primary winding given voltage rating. So this is how we'll transform the voltage base from one section to the another section by means of transformer voltage ratio. So in the given problem, the impedance of the components of power system are expressed either in ohms or in per unit, which is calculated using the component rating as the base values. In reactance diagrams, the resistances are neglected and reactances of all the components are expressed on a common base. Hence, starting from one end of the power system, the reactances of each component should be converted to per unit reactances on the selected new base. when the specified reactance of the component is in ohms. So this formula is useful in calculating the per unit reactances. The x ohm is equals to x per unit is equals to x ohm into MVA base nu divided by kV base nu square. This is when the reactance of the component is in ohms. When the specified reactance of the component is in per unit, when it is given in per unit on the component rating as base values, then consider the component rating as a volt base values. We need to consider them as a volt base values, and selected MVA base calculated kV base values as new base values. Now the per unit reactance on a new base can be calculated using the formula x per unit nu is equals to x per unit volt into MVA base nu divided by MVA base volt into kV base volt square divided by kV base nu square. Thank you for watching the video.